In this problem, let's solve a radical equation that has two radicals in it. Just one example. Here we go. We'll solve the square root of 2x plus 8 minus the square root of x plus 11 is equal to negative 1. Now, a lot of people think that this will have no solution because its radicals equal to a negative, but that's only if you have a single even radical equal to a negative number. If you have multiple radicals, so 2 or 3 radicals in your equation, one radical could be smaller than the other one, and when you subtract them, you could get a negative out. So I don't know that this is a no solution or if it has a solution. I have to solve it. And the first thing that we want to do is we want to isolate what we think of as the ugliest square root. And it really doesn't matter which one, but I'm going to isolate the square root of 2x plus 8. So here we go. I'm going to do that by adding the square root of x plus 11 to both sides. So now this is beautiful because on the left-hand side, the square root of x plus 11's cancel. And all we're left with on the left-hand side is a 2x plus 8 in a square root. On the right-hand side, however, this negative 1 and the square root of x plus 11, they're certainly not like terms, so I'm going to leave them separated and write it as the square root of x plus 11 and then minus 1 outside the square root. Okay. So now what we can do, that we have at least one of our square roots isolated, is now we can undo the square root by squaring both sides. Now we have to be especially careful when we square both sides. We are only squaring the left side of the equation and the right side of the equation. So we can only put one set of parentheses in a squared on the left and one set of parentheses in a squared on the right. What we could not do is distribute the squaring through on the right-hand side. There's other videos that I've made about why not, so I'm going to just defer to those at the moment for why we can't square everything one at a time. Okay, so here's what we do when we square both sides. On the left-hand side, where we had our square root isolated, the square root of 2x plus 8 all squared is going to cancel to simply 2x plus 8. That's lovely. Unfortunately, on the right-hand side, we have the square root of x plus 11 minus 1, multiplied by the same thing. And this needs some sort of multiplication. I call it FOIL. So if we're going to distribute all this out, so let's see, square root of x plus 11 times itself, the square root of x plus 11, that's just going to be x plus 11. And then the square root of x plus 11 times a negative 1 is negative square root x plus 11. We have another one of those. Negative 1 times the square root of x plus 11 is negative square root x plus 11. And then finally, negative 1 times negative 1 gives us positive 1. Super cool. Okay, let's combine all those like terms on the right-hand side. So we have 2x plus 8 equals x plus 11 plus 1 will make 12. And those square roots with x plus 11, those are like terms. So we can do, let's see, if we think of this as a negative 1 root x plus 11 minus another 1 root x plus 11, that's negative 2 root x plus 11. Okay, we're getting closer. Let me point out what I like about what we have right now. What I like about this is we went from having 2 square roots in our equation to only having 1 square root, 1 radical in our equation. So now we're going to isolate this 1 leftover radical. Okay, I think that's easiest by, let's subtract x from both sides, and let's subtract 12 from both sides. So we should get 2x minus x is x. 8 minus 12 is negative 4. Then on the right-hand side, the x's and the 12's cancel, and we have equals negative 2 times the square root of x plus 11. Quick note, I cannot make this 12 minus 2 a 10 because they're not like terms. This 12 is a constant term, but this 2 is attached to the square root of x plus 11. They're not like terms. They're tempting to combine, but I cannot combine those. Okay, I'm totally welcome, if I choose, to divide both sides by that negative 2 to make it cancel and totally isolate the square root. But I like to avoid fractions wherever possible, and while the 4 reduces with the 2, the x will not. So I anticipate fractions if I do that. So here's what you can do if you want to avoid those fractions. I'm going to square both sides just like I did previously. Careful to put only one set of parentheses squared on the left and another set of parentheses squared on the right. And on the left-hand side, just like before when we were multiplying out the square root of x plus 11 and then minus 1, because we had the subtraction sign outside of the square root, we had to FOIL or distribute, however you want to call that. So same with the x minus 4, we need to multiply that out as x minus 4 times x minus 4. So that's going to give us x squared minus 4x plus 16. So x squared minus 8x plus 16. And then on the right-hand side, we have no addition or subtraction that is outside the square root, which is lovely. But we do have some multiplication happening here with the negative 2 and the square root. The square root will certainly cancel with the square, so we'll have, instead of the square root of x plus 11, we'll have x plus 11. But what we need to be careful about here is the negative 2 is not tucked inside a square root. So it needs to be squared. So if we square negative 2 times negative 2 is 4. Cool. Okay. Now that we've gotten to this part, all we need to do is isolate, well, not isolate x, sorry, we have an x squared. We need to get 0 on one side and then hope that it factors, but if not, we can fall back on the quadratic formula. So just to recap really quickly, what we did to get here is we picked one of our square roots and isolated it, squared both sides. The side that we isolated the square root was lovely because it canceled, but the side that we weren't able to get totally isolated, have the square root totally isolated, it needed to be multiplied out. Combined our like terms, and then isolated the remaining square root to do that process one more time, squaring both sides, and now we can solve. So let's see, this is x squared minus 8x plus 16 equals 4x plus 44. And getting that 0 on one side by subtracting the 4x and the 44. And we're running out of room. We've got x squared minus 12x. What's that going to be? Minus 28 equals to 0. Okay, and that factors not to 7 times 4, because that certainly doesn't give us 12, but minus 14, x minus 14 and x plus 2 will multiply to give us the x squared minus 12x minus 28. So initially, our two answers are x equals 14 and x equals negative 2. Okay. Here's the crummy part about these problems is you always have to check your answers at the end. There isn't a great pattern I can share with you for determining which one might check or how many of them check. So we're just going to go through and check these. So I'm going to clean this up and leave room just for the checking part. All right, here we go. Let's check the x equals 14 first. So So when we check, we plug it into the original question, the original problem. So everywhere I see an x, I'm going to replace it with a 14. So 2 times 14 plus 8 in the square root minus the square root of 14 plus 11. And I hope this equals -1. Okay, let's simplify a little more. 2 times 14 is 28. So 28 plus 8 minus the square root 14 plus 11 is 25. And I hope this equals -1. But we have a problem. 28 plus 8 is 36. So the square root of 36 minus the square root of 25 is 6 minus 5, which is not equal to -1. It equals +1. So that tells us that x equals 14 is not one of our solutions. However, when we plug in the -2, okay, so 2 times -2 plus 8 minus the square root of -2 plus 11, and we hope this equals -1. This looks better. 2 times -2 is -4 plus 8. -2 plus 11 is 9. -4 plus 8 gives us the square root of 4. Whoops. There we go. And square root of 4 is 2, minus the square root of 9 is 3. You know what? 2 minus 3, it is -1. Sweet. So x equals -2 is our only answer.